Hello and welcome to Math 131 Week 2, Introduction to Working with Data. Just as a quick friendly reminder, you are to follow along with this lesson here on the webpage and this video to complete Week 2 notes. And then when you're comfortable with the material, you'll go ahead and complete Week 2 assignment. And both of these are part of your final grade. This video is going to be hopefully a short half lesson for Week 2. We'll cover only missing data and summarized data, and we'll leave for a follow-up video creating, editing new variables and categorical variables. So let's get started. We're going to be using these common packages that we'll use for most lessons throughout this course. I've added a flag, they're called, -q, to try to tell pip to install and update NumPy, Pandas, and Plot9 quietly. That means we'll get less printing than we otherwise would, hopefully. That you can see there's still some printing here. So we'll let that update, and then we will restart the runtime. It's restarting here. You can see it's now restarted. I'll clear the output because we don't need that, and we'll go ahead with our lesson for Week 2. We're going to use a new data frame. This is called mSleep. It's about mammals' sleep patterns. We're going to make a plot in this video, so we'll import plot9 as pn, and we're going to use NumPy, so we'll import NumPy as np. Here is our data frame about mammals' sleep behavior. There are 83 rows and 11 variables. Each row is a new animal with, information about that animal. Apparently cheetahs are from the order Carnivora, that kind of makes sense, and they have a conservation status of least concern. This cheetah did not have a brain weight measured, but it did have a body weight measured. What we're going to do for this video is get started with a relatively easy topic of looking at the missing data in a data frame. All of these NaNs stand for not a number. We're effectively saying that there's not a number in our data set for the cheetah's brain weight. There's not a number for the mountain beaver's brain weight. These missing data are frustrating in a number of different ways. First, you wish you had data for those, but we don't in this case. So we're going to start figuring out how to deal with these data in terms of code. So our first step is going to be, let's just take from our data set the column brain weight. Now the columns of a data frame have a built-in function called hasNans. And this just returns true or false. If a column has NaNs, nan data, then it will return true. Since we see that brain weight has nans, this function returns true. On the other hand, awake looks like, I don't know this, I'm guessing here. It looks like it doesn't have any data, any missing data, so it returns false. But we're going to work with brain weight here. So here's a quick true or false. Does the column of interest have any missing data? It does. Okay, what can we do about that? Well, in some cases, you don't really need to do anything about that. Like NumPy's function mean will throw out the missing data, add up all of the actual data you have, and divide by however many actual data you have. That's relatively close to what you want to happen. On the other hand, the NumPy function size counts all of the nans as part of the size of the column. Now, that both makes sense and doesn't make sense. It makes sense because there's like literally a spot here, and we want to know how many spots there are in this column. But it doesn't make sense in the case that we know brain weight has nans, and so we're not getting an accurate representation of how many nans we have. So let's see if we can work towards figuring out how many missing data we have. So here's another built-in function, is NA, and then it's a function with no arguments, so you got to put parentheses after it. And it returns a Boolean column. That is a column full of Boolean values. The 0th row of the column brain weight is missing, so it reports true there. But the first row of the column brain weight is not missing, so it reports false. On most programming languages, trues are treated as 1 and false is treated as 0. So if you just calculate the sum of the NAs in the column brain weight, we can see that we have 27 missing data from this column. And if you put a tilde right before that, remember this tilde is going to flip all of the trues in this new column to falses, and it's going to flip all of the falses to trues. So here is a count of actual data in the column brain weight. Okay, that's our first step towards working with missing data in a column. We can ask, does the column have missing data? We know that mean and some other functions like standard deviation will appropriately ignore the nans, but on the other hand, some functions like NumPy's size function don't necessarily ignore the nans like you might expect, and you have to do a little bit, let's call it some trickery, to appropriately count the number of actual data you have in the column. Next, we're going to look at a plot. So we're going to use plot9 and the function ggplot. We're going to act on the data frame msleep. And a nice feature about plot9's function ggplot is that you are literally going to add onto a basic frame some layers of information. So in this case, we're going to add on the geometry of a bar chart, and we're going to specify the aesthetic of conservation. This is rather strange code at first, so let's just take one more second to read through it, and then we will see what the function gives us. So this highlighted piece of code here is going to say, set up an empty plot for us using the data frame msleep. Then we're literally going to add on to that empty plot the geometry of a bar chart where the aesthetic is basically saying on which axis do you want what variables. So we're going to say onto the x-axis, please put the variable conservation. Now, this plot looks like this, and it's effectively taking a categorical x-axis variable, and for each category in the categorical variable conservation, it's going to count with the height of the bar how many data are within the conservation status CD. How many data, how many animals in this case, how many animals are in the conservation status domesticated. So we can see from this bar chart that most of our data is actually nans, and as far as the groups go within here, and least concerned is the second most common conservation status of the mammals in this data frame. So you remember, we're trying to deal with nans, and having nans be the biggest group within the conservation status is a little bit annoying, because it's effectively scaling the entire height of this bar chart to the height of nans. Well, that's not really helpful. We'd probably prefer to scale the height of the bar chart to least concerned, the next highest group. So our next step in dealing with missing data is removing the missing data we have from the data frame msleep. Now there's another built-in function to a data frame named dropNA. And you specify a subset of columns that you want to drop from and you specify a subset of columns for which you want to scan through and drop any row that has missing data. There's a few caveats to the function drop_NA that I'll discuss in a second, but first let's just move on with our plot and see if it actually works as intended. So we're going to create a new data frame named df. So if we just copy and paste the code from above, we'll just replace msleep with df, and otherwise we'll keep all the things exactly the same. And so you can see here we have removed the nans from our data frame. So this whole column, which was previously here for nans, is gone. And we now have a bar chart appropriately scaled to the conservation status least concerned. I'm just going to add a little bit more about the function drop_NA. If you leave out this argument, this keyword argument subset equals, if you leave that whole keyword argument out, then the function drop_NA will go through every column that has NAs. And it's going to remove any row that has NAs in it. Now that's not great, because notice we were only using the variable conservation status. But notice sleep cycle has some nans where conservation does not. So if we call drop_NA without the keyword argument subset, it would remove some rows of our data set because other variables have nans than the variable we're currently interested in. So drop_NA is a super helpful function, but you do have to be very clear with the keyword argument subset about exactly what variables you're interested in checking for NAs and then removing those rows. Now, I specified the keyword argument here as a list. You could actually specify it as a string, but I'm just reminding you that you could fill in other variables to check for missing data. I just happen to only need the variable conservation, so that's the only one I used. Our last topic for this video is going to be summarizing data. So not necessarily in plots here, but summarizing in code and maybe little tables some of the variables we're interested in. We'll start by recreating as a table the bar chart above. So if you call out the function value counts associated with the column conservation, and then say drop_NA equals true, we will get a table sorted that is basically the equivalent of this bar chart above. Notice least concerned has height 27. That wasn't immediately obvious that it was exactly 27 from the bar chart, but here's a table that indicates it for us. Domesticated has height 10, and that's exactly the bar chart we have above. There's two other ways we can quickly summarize a column using pandas data frames. We'll continue to act on the column conservation, and we'll just call the built-in function describe. So you can see here, describe gives us a count of the actual data we have. Top is telling us the category for which there is the most animals. So least concern has the most animals in it. Now here we call describe on a categorical variable, but you could also call describe on a numeric variable like brain weight. And in this case, we get a count of the actual data we have, which directly matches our count above of actual data. We also get the mean, which we calculated above, a standard deviation, which we did not, a minimum and a maximum, and the first, second, and third quartiles, if you're familiar with those. We'll skip for now. But they are useful information in order to describe or summarize a numeric variable.